Welcome to another episode of Single Variable Madness. In this question, we have to find all integers x, such that this expression, the square root of 3x minus 5 divided by x plus 1, is also an integer. So with a question like this, it's always usually a good idea to introduce a new variable. So let's do this. Let's equate this expression right here. Let's write it again. Square root of 3x minus 5 over x plus 1, and let's equate it to another integer n. But then we're going to say that n is greater than or equal to 0. So we're limiting n to non-negative integers because we don't want the square root of this number to be a negative integer. That won't make sense. But anyway, now that we have this equation right here, let's see if we can set x by itself. So let's do some manipulation right now. Let's square both sides, so we get 3x minus 5 over x plus 1 equals n squared, and then let's multiply x plus 1 on both sides. So by doing that, you get 3x minus 5 equals n squared times x plus 1. And now what should we do? Well, if we're trying to set x by itself, let's see if we can get all the x's on one side. So let's see, let's bring the n squared, okay, after multiplying n squared by x and 1, let's take the n squared times x term and take it to the left, and let's factor out the x. So we get x over 3, and then it's a minus n squared. It's plus n squared here, but once you subtract it, you get a minus n squared. And let's bring the 5 over here, and that's equal to 5 plus n squared. And now let's divide 3 minus n squared on both sides. So you get x equals n squared plus 5 over 3 minus n squared. So now you have this equation right here. And now we're just looking to find, remember, our goal is to find all integers x such that this is an integer. So now we get this. And now we have to find all integers n such that x is an integer. So how do we do that? Does that make this question any easier? And the answer is yes, it actually does. Because notice this. You have an n squared plus 5 over here and a 3 minus n squared over here. This 3 minus n squared is pretty much n squared minus 3 times negative 1, right? And then we have an n squared plus 5. So we can actually take this fraction and put it into two parts, like this. We can say that x is equal to n squared minus 3 divided by, and instead of saying 3 minus n squared, I'm just going to say minus n squared minus 3. It's the same thing, and I'm just factoring out negative 1. And then we add 8 over, again, negative n squared minus 3. So essentially, these two fractions are the same as this one, because when you add these two together, the minus 3 and the plus 8 turn into plus 5. Now, the reason we wrote it like this is because look at this fraction right here. N squared minus 3 divided by negative n squared minus 3. You can cancel, just putting parentheses around, you can just cancel n squared minus 3 from both sides. So you get x equals negative 1. That's just what it is. 1 divided by negative 1, or negative 1, plus 8 over, and then let's just write this as 3 minus n squared one more time. So now it's much easier to find the values for x now, because now we don't have to worry about this other fraction. We just have to worry about this fraction right here. And actually, finding the new integer values for this fraction is rather easy. Remember, we're trying to find the integer values for this fraction because an integer plus this integer will equal another integer. And we're trying to find all the integer values of x over here. And we already said that n is also an integer. But n is also greater than or equal to 0. So that limits our options for what we can put over here. For instance, we can't put any negative numbers. And we can't put just any positive number that we want, because it has to be able to divide 8. So let's just try the first couple of integers. Let's try n equals 0. Well, then that would give us 8 divided by 3 minus 0, or 8 divided by 3. But that isn't an integer, so we can scratch that out. Let's try n equals 1. So we get 8 divided by 3 minus 1, 8 divided by 2, and that's 4. So that actually works. You get, so for n equals 1, you get negative 1 plus 8 over 3 minus 1, 2. And that's equal to 4 minus 1, or 3. X equals 3. So let's try another one. Let's try n equals 2. Well, that's 8 over 3 minus 4. That's 8 divided by 3 minus 4. So that's 8 divided by, 8 divided by negative 1. So that's negative 1 minus 8. And let's find that. Negative 1 minus 8 is, for n equals 2, we get negative 1 minus 8, and that's equal to negative 9. So we find another value right here. Let's just try a couple more. We get 8 divided by 3 minus 3 squared, so that's 8 divided by 3 minus 9. 8 divided by negative 6, no, that's not an integer. Let's try 4. Well, actually, after you try 4 and onwards, you're going to get a bigger number in the denominator than the numerator, so you're never going to get an integer. So in fact, these are the only values of x and n that work. So now let's write it over here. X can equal 3, and x can equal negative 9. And these will give us integer values when we plug in these x values into here. Let's test it out. If we plug in x equals 3, we get 3 times 3, 9 minus 5, which is 4, divided by 3 plus 1, or 4. So you get the square root of 4 divided by 4, the square root of 1, that is 1. And now let's try negative 9. Well, negative 9 times 3, so negative 27 minus 5, negative 32. And then negative 9 plus 1 is negative 8. So negative 32 divided by negative 8 is 4. The square root of 4 is an integer. So therefore, we have found our two x values that, when plugged into this expression right here, will also give us an integer value. And we are done.